In recent weeks, a mysterious interstellar visitor known as 3I/Atlas has ignited global fascination, speculation, and controversy. As telescopes around the world track its movement through our solar system, debates have emerged not only about what this object is, but what it represents for humanity's understanding of the universe. While some voices have ventured into extraordinary territory, suggesting the possibility of alien technology, others urge caution, scientific rigor, and restraint. Among them is theoretical physicist Michio Kaku, who believes the comet's strange behavior can be explained without invoking extraterrestrial intelligence. 3I/Atlas is classified as an interstellar object, meaning it originated outside our solar system and is merely passing through. This alone makes it exceptionally rare. Only a handful of such objects have ever been detected, and each one offers a fleeting opportunity to study material formed around distant stars. Yet 3I/Atlas stands out even among these rare visitors. Observations indicate that it lacks a traditional comet tail, displays unusual chemical signatures, particularly involving nickel, and appears to have changed velocity as it passed near the Sun. These anomalies were highlighted by Avi Loeb, a Harvard professor known for challenging conventional assumptions in astrophysics. Loeb has publicly questioned whether natural explanations fully account for the comet's behavior, at times raising the speculative possibility that 3I/Atlas could be an artificial object, perhaps even a probe or relic created by an advanced civilization. Such claims have captured public attention, fueled headlines, and ignited online debate. But Kaku, speaking on News Nation Prime, offers a more grounded interpretation. He argues that the object's oddities are not evidence of alien engineering, but rather signs of extraordinary age. According to Kaku, most comets observed within our solar system are between 3 and 4 billion years old, formed during the early stages of planetary development around our Sun. By contrast, 3I/Atlas may be as old as 7 billion years, meaning it predates the solar system itself. Over such an immense span of time, the object would have traveled through vastly different cosmic environments, encountering diverse radiation fields, interstellar gases, and stellar debris. This is a very old object, Kaku explains. And because of that, its chemical composition is not what we expect from an ordinary comet. One of the most puzzling observations involves nickel. Comets typically release water vapor, carbon dioxide, and other volatile compounds as they heat up near the Sun. Nickel, however, is rarely observed in significant quantities. Yet spectroscopic data suggests that 3I/Atlas is emitting nickel-rich material, an anomaly that has raised eyebrows across the scientific community. Kaku believes this, too, can be explained by age. Over billions of years, the comet may have accumulated trace elements from multiple star systems, gradually altering its composition. What appears unnatural, he argues, may simply be unfamiliar. The universe is not uniform, Kaku says. Different regions have different chemistries. Over 7 billion years, this object has had plenty of time to pick up things we don't normally see. Another point of contention is the comet's apparent acceleration after passing close to the Sun. Loeb has suggested that this could indicate propulsion, an idea that naturally leads to speculation about artificial engines. Kaku disagrees. He notes that comets are fragile bodies, often riddled with cracks, voids, and volatile pockets. As they heat up, pieces can break away, releasing jets of gas that alter their trajectory. There could be many reasons for a sudden spurt in velocity, Kaku explains. A fragment breaking off, uneven outgassing, internal stress. None of these require an engine. In other words, acceleration alone is not a smoking gun. The broader concern, Kaku warns, is not curiosity or imagination, but the manner in which speculation is communicated. He emphasizes that science thrives on questioning assumptions, but those questions must be accompanied by probabilities, evidence, and clear uncertainty. Speculation is fine, he says, but you have to quantify it. Is this a 1% chance? A 10% chance? Otherwise, you risk panicking the public. This distinction is critical in an era where sensational claims can spread instantly across social media, often stripped of nuance. For many viewers, the line between scientific hypothesis and science fiction becomes blurred, especially when authority figures speak publicly about extraordinary possibilities. Meanwhile, NASA has taken a cautious stance. The agency has confirmed that it possesses high-resolution images of 3I/Atlas, reportedly taken on October 2nd, and has stated that the object poses no threat to Earth. The comet is expected to make its closest approach around December 19th before continuing on its trajectory out of the solar system. Loeb has urged NASA to release all available data so independent researchers can analyze it. On this point, Kaku agrees. Transparency, he argues, is essential, not because the data will reveal alien technology, but because open science builds trust and accelerates understanding. The data should be released, Kaku says plainly. Let scientists look at it. Let's do this properly. The debate surrounding 3I/Atlas highlights a deeper tension within modern science. The balance between openness to revolutionary ideas and adherence to rigorous standards of evidence. History shows that many groundbreaking discoveries, from heliocentrism to quantum mechanics, were once considered radical. But history also teaches caution. Extraordinary claims require extraordinary evidence, not just anomalies. At present, no such evidence exists to support the idea that 3I/Atlas is artificial. Its trajectory, composition, and behavior, while unusual, remain consistent with known physical processes, especially when extended across cosmic timescales far longer than those typically considered. Interstellar objects like this one are not messengers from alien civilizations. They are messengers from deep time. They carry within them the chemical memory of ancient stars, long-dead planetary systems, and regions of space humanity may never visit. Studying them expands our understanding of how matter behaves beyond the narrow confines of our solar neighborhood. In this sense, 3I/Atlas is extraordinary enough without being extraterrestrial technology. It is a relic older than Earth itself, shaped by forces operating across billions of years. Its passage through our skies is brief, but the insights it offers could reshape models of comet formation, interstellar chemistry, and planetary evolution. As the object recedes back into the darkness between stars, the debate will likely fade from headlines. But the larger lesson will remain. Science advances not by chasing the most exciting explanation, but by patiently eliminating alternatives, measuring uncertainty, and resisting the temptation to leap beyond the data. There's no smoking gun here, Kaku concludes. Just a very old, very interesting comet. And sometimes that is more than enough.